Hello students, welcome back to the lecture series of Inverse Trigonometric Function, and this is our lecture number 6. And in this class I am going to discuss about a very important graph of the function y is equal to cos inverse of cos x. So let me go through the video. So this is our function y is equal to cos inverse of cos x, and we all know that to draw the graph of a function we have to know about the domain of the function, the range of the function, whether the function is periodic or not, and if it is periodic, what is its period. So all of this thing you have to know before draw the graph of this function. So first you see what will be the domain of this function. The domain of this function is, you see this cos function, cos of x, this cos function, its domain, cos function domain is the set of real numbers. We all know this one, it is the set of real numbers. And again, whatever be the value of x as a real number, then cos x, this cos x, it is always in between -1 and 1. That is, the range of the cos function is -1, 1. That means the input of the function cos x, cos inverse x here, is the function cos x. That means the input of cos inverse function is only from -1 up to -1 up to 1. So for this, if you use this 1 value for the cos inverse function, then it will be cos inverse of 1, and cos inverse of 1 is equal to simply 0. We know this one. And similarly, if you take cos inverse of -1, this will be equal to pi. So the range of the function, total function, entire function cos inverse of cos x, will be from 0 to pi. So this is the range of the function, this is the range, and this is the domain, this is the domain, this is the domain. So before the drawing of the graph, we erased the screen. Then you see the domain of this function is equal to the set of real numbers. I just told you this is the set of real numbers, domain for the value of x, and then the range of this function is obtained as 0 pi, that is already discussed. And now you see this cos function, this cos function is a periodic function with period 2 pi. We know this one from the first year, and so the domain of this entire function will, and so the period of this entire function will also be 2 pi. So I am writing here period of this function is 2 pi. That means we will draw the graph of the function for only one branch from 0 to 2 pi. Then after that the graph will be repeat and repeat again. So let me take the graph only. Obviously this graph y is equal to cos inverse of cos x will be straight line in the different branches of the function, because it will be a linear equation. Y is equal to x type, mx plus c type equation we will get, y is equal to mx plus c type equations will be obtained. So that therefore they will be straight line. So first let me take the graph of the function here. This is the graph of the function. You see here in the branch 0 to pi, in the branch 0 to pi, when x is from 0 to pi, then we will have, it is simply y is equal to x, because 0 to pi, this is the principal branch of the function cos inverse of cos x, and therefore it is simply y is equal to x. That is the line, this one. This time cos inverse cos x will be equal to x, because x is in the principal branch 0 to pi. Then when we cross the point pi here up to 2 pi, this is the whole branch, so from pi up to 2 pi, then you can try for some values here, you can try some value. You see, if we take for the next branch, if we take y is equal to cos inverse of cos of pi, then is equal to cos pi is simply -1, and cos inverse -1 is again pi. So our point is pi 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 is the point. Our point is pi. You see here, this point is pi and this is pi. Then if we take say 3 pi by 2, x is equal to, here x is equal to say 3 pi by 2, then in that case we will get here, you see, if I take here y is equal to cos inverse of cos 3 pi by 2, then it will be is equal to cos inverse of cos 3 pi by 2 is obviously can be written as 2 pi minus pi by 2, is not it? 2 pi minus pi by 2. And after this you see here is equal to cos inverse of, and what about cos 2 pi minus pi by 2? It is in the 2 pi minus fourth quadrant, and so cos is negative positive number, and so it will be simply cos of pi by 2, and cos pi by 2 will be is equal to 0 only, that means cos inverse of 0, and so the point is only 1 because cos inverse 0 is equal to 1. So our point is 3 pi by 2, then 0 1 3 pi by 2. Sorry, it will not be 1. Cos inverse 0 is equal to, I'm very sorry, cos inverse 0 is equal to pi by 2. It is simply pi by 2. So what is the point now? The point is 3 pi by 2 and then pi by 2. The point is 3 pi by 2 and pi by 2, and using this point in the graph, so x is 3 pi by 2 and it is only pi by 2. You see this point is pi by 2, and for 2 pi, when you use 2 pi, then cos 2 pi, here you see here cos 2 pi will be is equal to 1, and cos inverse 1, this is equal to 0 again. So we will have the point as 2 pi 0, mean this is 2 pi 0. So the graph is from this part to this part. You see here graph is from this to this, but this time the straight line is with negative slope. So before that I am clearing the screen. You see it is now have a negative slope, and the line will be, you see, the line will be y is equal to of this type, y is equal to it is minus x plus some constant c. Slope is -1 now, so minus x plus constant c, and this graph, that is this line is passing through the point 2 pi 0. So we use 0 here, minus 2 pi here, and plus c, that will be equal to c equal to 2 pi only, and therefore the straight line this in this time is equal to minus x plus 2 pi. So this is the straight line. Now we are to take the graph of the function as from here pi to 2 pi. So this is the line 2 pi minus x, and in this branch it is simply x. Now we can repeat this graph for the other branches also, because it is a periodic function. So this graph will be repeat again here, it will be repeat again here and so on. So I think you understood the graph. Now we take the next screen. Prove that cos inverse of 2x square minus 1 is equal to this whole expressions. So first of all we take a substitution for x is equal to cos theta. So is equal to this one, x is equal to cos theta, mean cos inverse x is equal to theta, and since it is a function, cos inverse function, therefore the domain is from -1 to 1, and this theta will lie between 0 to pi, you know that one. So after this, you see cos inverse of this branch will be equal to cos inverse of 2. This is cos theta, so cos square theta minus 1. And after this expression can be replaced by cos 2 theta. You know that one. So left hand side is remaining same, is equal to cos inverse of, this is cos 2 theta only, mark it by 1. Now we do not remove this cos inverse and cos in all cases. It can be removed by different values for different branches. So now we start with this expression by the domain of the cos inverse function and range of the cos inverse function. So now theta is belongs to 0 pi. I already told you that this theta means the range of the cos inverse function is from 0 up to pi, and our angle is 2 theta here. So multiply by theta here, 0, this is 2 theta and this is 2 pi. Now from 0 to 2 pi, we have two branches of the function as obtained from the graph. You can see here, this from 0 to 2 pi, it is from 0 to 2 pi. It has two branches. From 0 to pi, this is one of the branch, and pi to 2 pi, this is the second branch. So we will take these two cases. For 0 to pi will be one of the case, and for pi up to 2 pi there will be the second case. So we prove this for part wise. So for the first part, that is the first case, from 0 to pi, and from 0 to pi theta will lie between 0 to pi by 2, and you see theta will lie between 0 to pi by 2. But what was our substitution? This x is equal to cos theta, and theta is equal to cos inverse x. Therefore if I take cos in all of these terms, here cos 0, this is cos theta, it is cos pi by 2, and cos function is this theta. Actually I am replacing this value of theta here, cos inverse x. So if I take cos inverse x here, you see here I am writing here, it will be more clear to you. So after this line, you see, after this line, if I take 0 less is equal to, it is taken as cos inverse x as the substitution you already know, up to pi by 2. But if I take this cos inverse in all of these sides, then cos inverse function is a decreasing function. So we will have actually cos inverse of sorry, not cos inverse, I am really sorry. Actually this cos inverse is taken in the left hand side as inverse function. That means it will be cos of 0. Now cos inverse function is a decreasing function, so it will be greater or equal to x, and greater or equal to simply here also cos of pi by 2, and that can be written as cos pi by 2. I am writing here cos pi by 2 is 0, then it is less than is equal to x, less than is equal to cos 0 is only 1. This cos 0 is 1. So this is the condition on x. You see here I am writing that, and as well clearing the screen. You see this is from 0 to 1. And now we go to this equation number 1. Our branch is from 0 to pi, from this one 0 up to pi. 0 up to pi is this branch, and it is the principal branch of the cos inverse function. And in principal branch, the cos of cos inverse will remove each other. That means it will be only y is equal to x type, mean it is y. If you consider this total term as y, so y is equal to x type mean 2 theta. So this time this term will be equal to 2 theta only. So I am writing that one 2 theta, and theta was is equal to this cos inverse of x using here. So cos inverse of 2x square minus 1 is equal to 2 times of this is cos inverse x, and where x is from 0 to 1. That means this is the relation for this branch. Again we take the next branch. I already told you from 0 to pi. Now I will go from pi to 2 pi, and from pi to 2 pi, if we remove this cosine inverse and cosine inverse and cos, then it will be this type 2 pi minus x, and we will have here 2 pi minus 2 theta. Okay, so we take the next screen. So if this is our second case, then theta will lie from pi by 2 up to pi, and so this is again as in the earlier, as done earlier. You see, this is you can see here. Okay, so actually our relation is this. Then pi by 2 is already here, less than theta is equal to cos inverse x, and less than or is equal to pi. Then take cos inverse function on both sides, cos as cos, so we will have cos pi by 2, and it will be greater than, because cos inverse is decreasing function, and it is x greater or equal to, this will be cos pi only, and so this cos pi is writing here first. So cos pi value is -1, then less is equal to x, and less than cos pi by 2, this value is written here, it is only 0. So the condition on x is from -1 up to 0 is this one. You got it? And then I am clearing the screen again. So equation 1 implies, equation 1 was cos inverse of 2x square minus 1 is equal to cos inverse of cos 2 theta, and now cos 2 theta will be this term. You can see again the graph. You see this one from pi up to 2 pi, that means from here up to here, pi up to 2 pi. This cos inverse will remove, the cos inverse will remove, actual function is this one. You see, I am writing here, actual function is, it is actually like this, cos y is equal to cos inverse of cos 2 theta type we have, but 2 theta is from pi up to 2 pi, and therefore it will be is equal to 2 pi minus 2 theta, because this time the straight line will be of negative slope, meaning 2 pi minus 2 theta. Okay, 2 pi minus 2 theta, then just replacing the value of theta here, that is the answer. And the condition on x is already discussed here. This is the condition on x, this one. Okay, so I think you understood this one. We take another property. So to prove that this cos inverse of 4x cube minus 3x is equal to this, all of these expressions. So as done earlier, this time I am taking cos inverse x is equal to some theta. So cos inverse x is equal to theta, therefore it will be it will imply x is equal to cos theta only, and then this left hand side, cos inverse of this will be equal to, cos inverse of this will be equal to cos inverse of x is equal to what? X is equal to cos theta. So 4 cos cube theta minus 3 cos theta, and so this is actually cos 3 theta formula. So I am writing cos inverse of this one is equal to cos inverse of this total part is equal to 3 theta only. So let me mark it by 1. Now we see what is the range of 3 theta. Actually our substitution is cos inverse x is equal to theta, that is the range of theta is from 0 to pi. So 0 to pi, but our angle is 3 theta, therefore multiplying by 3 here, so 0 3 theta, it will be 3 pi. So this is our total branch from 0 up to 3 pi, but from 0 up to 3 pi, the graph of cos inverse of cosx function is different straight lines like this. This one is the graph. This is our branch now from 0 up to 3 pi, mean from 0 up to this is 2 pi, and this is 3 pi, 0 up to 3 pi from this. So there will be 3 different parts. One of the part is from 0 up to pi, then second part is pi up to 2 pi, then third part is 2 pi up to 3 pi. These are the 3 different parts of the graph. So we are to take for the first case from 0 up to pi, then for second case pi up to 2 pi, then for third case 2 pi up to 3 pi, and this will be the relation in the different branches. So let me take case 1, 0 up to pi, from 0 up to pi, this one. 0 up to pi, and it is the principal branch of the cos inverse function, and therefore it will be simply equation 1 will imply only 3 theta here. Cos and cos inverse will remove, and before that I am finding the condition on x. So division by 3 here, 0, theta and pi by 3 is equal to taking the value of cos inverse theta is equal to here cos inverse x. So if I take cos inverse here, then cos inverse is taken on both sides, and it is a decreasing function, so inequality sign will be reversed. So cos inverse of 0 is taken as 1, then not cos inverse 0, cos of 0 is taken as 1, and it will be cos inverse of theta will be x, this one, cos of theta will be x, and then cos inverse of pi by 3, cos of pi by 3 is equal to half, and this can be written as half up to 1, like this, writing in reverse order actually. So half up to 1, and then we take the equation number 1. This left hand side is already this one. I already told you this 3 theta, this 3 theta is in the principal branch now, 0 to pi. Therefore this term cos and cos inverse will directly removed, only 3 theta. Now replacing the value of theta only. So cos inverse of this is equal to 3 cos inverse of x, and for what value of x? X will be in between pi half up to pi, or half up to 1. That is the answer. And then we take the second case from pi up to 2 pi. Yes, from pi up to 2 pi. This time 1 will imply 2 pi minus 3 theta, as like this, 2 pi minus, here x is 3 theta, so 2 pi minus 3 theta. So let me take the next screen. This one is the relation. Then division by theta 3, here pi by 3, this is theta, this is 2 pi by 3. Then taking cos inverse x here, cos inverse x, and that cos inverse is taken on both sides as cos, so x will remain here. Cos inverse is decreasing function, so this inequality sign will be reversed as like this, and it is cos pi by 3, simply half, it will be x only, and greater is equal to cos of 2 pi by 3. Cos 2 pi by 3 is very simple. Cos 2 pi by 3 is like this. Cos of 2 pi by 3 is nothing but cos of pi minus pi by 3, and that is equal to cos of, sorry, not cos, is equal to minus cos of pi by 3, because it is in the second quadrant, cos negative, and so it is minus cos pi by 3 is simply half, so it will be minus half. I am writing that one. It will be minus half. For that I am clearing the screen. So the next one is from this one, you see pi up to 2 pi now. So here you see pi up to 2 pi, then cos will remove from equation number 1. And what was equation number 1? The equation number 1 is, I am writing here, you see it was simply on the right side actually, it is cos inverse of 4x cube minus 3x is equal to cos inverse of cos 3 theta. This was the equation number 1, but this cos inverse cos will remove for this branch pi up to 2 pi, as in this way. This is only 2 pi minus, and x is this time 3 theta, like this. Okay, so I am writing that. As like this one, very simple. Left hand side is remaining same. This is 2 pi minus 3 theta as seen from here, and 3 theta, 3 is remaining same, and theta mean cos inverse of x, so I am writing that one. So it is 2 pi minus 3 cos inverse of x, and this is the condition on x. Okay, so the next one, case 3. Now 2 pi up to 3 pi. 2 pi up to 3 pi. Again, you see what is the branch of theta. It is 2 pi by 3. Then theta, it is only pi by pi only. Then taking theta is equal to cos inverse x, and that cos inverse is given on both sides as cos function, and it is decreasing. Therefore cos of 2 pi by 3 I just obtained, it is minus half. Here x will remain, and this pi, cos pi, is equal to minus 1 only, and you write this part in increasing process as like this, in the reverse process actually, minus 1 up to minus half. Now you see the graph also. This time it is 2 pi up to 3 pi. You see 2 pi up to 3 pi. Then the line is like this. This time I have to take, this is minus 2 pi plus x. X means 3 theta here. So minus 2 pi plus 3 theta now. And theta is equal to obviously cos inverse x. So I write here cos inverse of 4x cube minus 3x is equal to this minus 2 pi remaining same, and plus 3 into x is equal to cos inverse of x, and this is the condition on x already obtained here. So this is the proof of the given problem, and I finish this class here, and in the next class I will take some entrance based question for JEE Main and Advanced. So be ready, we will begin a new series for the inverse trigonometric functions, and in that series we will solve some entrance based questions having multiple choice questions, actually MCQs, and those questions will be begin in the next class, and that will be a new series for our inverse trigonometric function. And today we finish this class here, so thank you very much.